Thank you, Susan. So when we look at this is part of three sessions that we talked about on the basics of project management. And I'll briefly go over what the first two were, but this one is independent verification and validation. And I categorize this as a fumble. As you can see our football folks up in the picture have just fumbled the ball. And I look at it as a fumble because it's one of those areas that is either overlooked, is addressed in the breach, or completely not even thought of. Also within project management, and it's usually not project managers who are there in the thick of it, who are there on the ground doing the work. It's usually senior managers that really don't think that it adds value. And they don't think it adds value because it was never shown the value that it adds or the risk that you can avoid with it. It's usually just lumped into testing. And, when the project starts getting behind its time and cost goals, testing is one of the first things that starts to go. Of course, if you're stopping testing, you've already stopped doing any documentation. So I'm sure that with the experience that all of you have, you've seen this happen in action. We want to look at both in information technology and operational technology environments for independent IV&V functions. And I'll talk about two examples of that. Really look at some of the real world examples. And what I really look at too is IV&V is not just software. Software is really one part of three parts that you've got to be cognizant of. You've got to understand the hardware and you've got to understand the processes. And all three of those things need to be part of any type of verification and validation plan. So those were that's what we're going to talk about. What we had talked about previously was basically blocking and tackling. We looked at stakeholder feedback, which is kind of the blocking that we want to go through. We want to make sure that personnel, shareholders, regulators, suppliers, vendors, multiple others, we identify the shareholders and understand what their issues are, what they care about, and how they impact our project. And we talked about this previously back in September. And then also we talked about the tackling portion of it, which is continuous status monitoring. We talked about that in October. So this is kind of the recap, the top end of those three basics of project management that we want to look at. And today, again, we'll look at the idea of independent verification and validation. Part of this was, a lot of this work was done as part of the course that three of us put together, Bob Futrell, Linda Shafer, who yes, happened to be related to, and myself put together a book, Quality Project Software Management, which was the basic textbook for University of Texas Cockrell School of Engineering software engineering project management course. So this was one of the key working areas that we were in when we put these together. So, not only have we really done it, but we've actually taught this stuff to a large group of people coming out of the University of Texas in Austin. First, a few definitions. And I think it's always important to understand when we look at the definitions. Independent, and that's fairly critical. If you've got a verification and validation group within your company, within your organization, within your project, they're not independent. When you look at independent V&V, you're going to have an organization that's technically, managerially, financially removed from the development organization. It may be someone within the same large company, depending on the size of the company that you work in, or it may be an outside group that you bring in on a regular basis to really do that verification and validation of the projects that you're doing, project or projects. Verification, you evaluate a system or component to determine whether the product of a given life cycle phase satisfies the conditions that were imposed at the start of the phase. And of course, all of us use some kind of project management phasing, some life cycle phasing that we have for developing products. I'll talk about some of these later on. Really, verification asks the question, are we building the system right? Are we building it in a correct fashion? Technically, are we looking at ensuring that we're using the right tools, we're using the right software stacks, we're using the right software tools and hardware tools? These are some of the things that I really want to be cognizant of. Validation, that's usually the end. It happens at the end with user acceptance testing. Are we building the right system? Is this what the user wanted? This assumes all the way along that you've been taking care to ensure that you're addressing all the requirements, that the requirements are met, that as requirements change, you're managing the requirements. That's something that in independent V&V, we always look at. So, are you building the system right? Are you building the right system? And is the organization independent from that? I always like to go to Google Trends and look at trends over time. So when I look at IV&V over on the right, or actually the left, you can see that there was a whole lot of interest in it back in the early 2000s. That's kind of flattened out by today. If I look at software ends up having kind of the same type of trends. So when we look at IV&V for software, we end up looking at the facts of, the interest has declined over time. I think a lot of that is because it hasn't been continuously emphasized. We haven't had the focus on it that we should. And in many cases, the idea of software is pretty much taken for granted. When you think of the amount of horsepower that your children have on their smartphones, and what you're dealing with when you're building systems yourself, you come to realize that software really is ubiquitous and that we're not paying attention to it because we know it's there. It's there all the time. Then if I look at software IV&V and put those two together, what's interesting is that, I love it when I get this on Google Trends or any Google search, you get the, your search doesn't have enough data to show here. So although there was software and IV&V had a lot, and I can tell you that the IV&V chart is not software IV&V. The IV&V chart, when I looked at the data behind it, focuses a lot on systems and hardware and doesn't focus directly on software. And you can see that as, the interest is just not there in software IV&V, at least not in Google. And I think that we can be fairly sure that if it's not in Google, it's probably a good chance that it's not being emphasized throughout the software development or systems development environment. One of the other things, we can't forget the working environment we're in today. And it's critical if you're going to do verification validation, either independently or not, you've got to have the people available. And remote work isn't going to go away. We're going to keep seeing that this is a percentage of paid full days work from home. And right now we're somewhere in the 40% area. So 40% of your folks that you're going to be working with are not going to be in the office. And that's just something that you have to look at. Of course, this is no different than, I think, back to when we first started doing offshoring. And we first started looking at having software development because we thought it was less expensive in places like India, the Ukraine, Russia, the Philippines, Vietnam, that our development teams were, fairly good size, but they weren't there in the office every day with us. We were here in the United States. One of the examples that I like to use is that we were building, when I was at Motorola, we were building a video teleconferencing system. And that video teleconferencing system, our customer was British Telecom. And so they were in London. The customer was in London. The architect for the system was in Motorola Aylesbury, which is north of London. The software was being developed at our Motorola software development group in Bangalore, India. The silicon we were using was being developed by our design center in Israel. And then the prototyping and management was in Austin, Texas. So you can imagine when we were trying to do verification and validation on the different parts as we went through phases, we would literally have a teleconference every morning at 7:30. And once a quarter, we would get together, all the management would get together in one of the remote locations. And once a year, everybody got together. So if you thought that it was less expensive to do something offshore, when you start throwing in the travel costs, it didn't become any less expensive than if they were sitting right next door. But you had to have that connection. So we see the same types of issues today. I see it today all the time here in Austin, Texas, where development teams, the only way they meet is they meet on Zoom. And they meet on Zoom usually once a day, sometimes twice a day. They all work on Slack. They've got all their other tools that they're using for project management and for development. So it is the thing that we've got to understand, that you're going to have to work with tools just like we're doing today with Zoom, and that's going to be part of it. So our focus on IV&V, let's talk about three things. Let's talk about where is it in the development lifecycle. We all use different development life cycles. If we don't have a life cycle, you just haven't recognized it yet. You do have one. And I think that what you're going to look at is that, and then we're going to look at software, an example, software in a government agency, a Texas state agency, and then hardware, software, process example, one of the things that, most of the work that we do within Athens Group. So let's first talk about where independent verification and validation is within the development lifecycle. And first, if I want to look at, here's a basic lifecycle, and although we'll talk about some other ones, we'll talk about Scrum, we'll talk about anything to reduce risk and so on. Throughout the lifecycle, if you think about it, it all comes down to a waterfall. You're going to be doing iterative processes in the waterfall, but you've got to have to do it. So when I look at where does IV&V occur, if I'm going to come in and look at a project from beginning to end, I'm going to look at, in the concept, what was the statement of need? How is that recognized? How are requirements derived from that? If I want to look at verification in the system exploration, the next step after the concept exploration, there's going to be some type of system interface spec. Think about this as a new banking system. Think of it as a new app that's going to be attached to one you have on your building that's going to be on your mobile phone. Think of it as a new financial analysis set of tools. So that system interface spec is really going to look at, what do I have to interface with? Things that you want to verify and validate there are looking at, can I get to those systems? How do I get to them? Is it logical? What gets drawn out in this system exploration when somebody from the outside comes in and start asking these questions is you immediately find out things like, I have to license a piece of software from someone. Or I thought I was going to use open source software, but it's got the wrong open source license to it. So I was going to interface with this one system, but realized that it runs on a 1980s era mainframe that is still on life support that's being used. Then verification validation in the requirements phase. And if I'm working on a software system, I want to look at the software specification requirements. I need to look at what were the requirements that I'm going to build this against. And so all of this is building one on another, my system need, my interface spec, and now my software requirements spec. And I'm verifying and validating these as I go along. And hopefully it's someone independent who won't pull any punches. Design, software design description, implementation. Now, finally, in my implementation, I've got my complete software validation and verification plan. That's something that I've been developing all the way along, but in implementation, that's where the plan's complete. And now I can look at, am I building the right system? Did I build the system correctly? Installation is going to part and parcel of installation is the report that comes out of my verification and validation. Are there key things that we're missing? Have I identified issues that I have to address? And that has to come before I do my installation. Finally, I get into operations and support. And now I want to make sure that I've validated and verified the user documentation. Is it usable? Can the user actually use it? Can I take this and install it? I think those are some of the key questions. Do I have the right screens, and do all the screens go to where they're supposed to go? Sometimes this isn't even complete until I get into operations and support. And then finally, I've got maintenance, documentation, and I can bring in and do verification and validation on the maintenance and do it maybe once a year, maybe once every 2 years, depending on the system that I'm using. And many times this maintenance verification and validation is built into the contract, especially for mission critical systems. And finally, I've got retirement. And hopefully I've retired the system and I've got everything archived and ready so I can learn from my successes and mistakes within that project. So V&V can occur anywhere and everywhere throughout the life cycle. You decide where you think is going to be best for you. If I look at a software test type of life cycle, then I've got verification feedback loops. Requirements, I'm going to be doing verification. I'm going to do verification of the system design, unit test, code and test, integration testing. You can see my feedback loops. Going down the testing side, I've got test planning, test design with the verification in each one of those steps. Do my system testing, and finally my acceptance testing where I do my validation, and that feeds back up to my requirements. And hopefully I have addressed all the requirements. If I have not addressed all the requirements, if I've missed some requirements, then I go through this loop again until I make sure I've gotten it correctly. Now, you can look at this as if you're doing things like Scrum, some Agile development, you can look at this as one of your passes through your Agile development cycle. It's possible you do that. What I found, and I'll talk a little bit more about Agile when we've used Agile for building systems, is that we end up shortcutting it. We don't go through the whole waterfall once I find a new requirement. And therein lies where a lot of the problems occur. And you may make it through validation. You may have made it through all the verification steps, but all of a sudden you realize when you're in operations and maintenance that you're failing. And there's things that you could have caught before that. Here's an Agile environment. And as I do my iterations, I've got my continuous integration, I'm refactoring, I'm building, I do daily acceptance. You may do it daily, you may do it weekly. When we got to a certain point after we'd gotten a critical mass of the requirements where we could start this building, then we went to daily. But until then, it was maybe every 3 or 4 days. If I do my iteration, I've got an iteration plan. I do my reviews. I do my release, do a release plan. I made some estimation in there. I then have my vision and my goals. So all of these, I can start inside out. I can start outside in. I can do it either way. But in the end, I hope I have working software. The one thing that you end up with in an Agile environment is verification and validation becomes assumed. And you start taking it that I'm going through these iterations, that I've done the work, and obviously I've verified and what I need to have done. That is not always the case. And within the Agile environment, you have to specifically build in your IV&V points. This is the typical life cycle for an Agile environment. And you, as the Agile developer, as the builder of this, have got to decide where you want to do verification and validation within this life cycle. Critical that you do that. It's not a given that is going to be in there just because somebody waves the magic Agile wand and says everything's going to be Agile and fine. In a unit test, I can look at it in the Agile environment, and as I'm doing my continuous building, kind of continuous integration, I can put the testing in place. And again, within the Agile environment, this is, we've got a lot of canonical knowledge about what you do in an Agile life cycle. But one of the critical issues, again, in this Agile testing is not verification and validation, and it's not independent verification and validation. So what you want to make sure that you're doing is, as you do, you do your planning, you do your requirements, you get your analysis and design, you do development, you do testing, and then you've got more evaluation. Well, as you do a release and you're putting those releases out, you have to ensure that through a verification process that you're meeting the requirements and that you're building the right product. So this is very much up to you to do that in an Agile lifecycle environment. So when I look at Agile versus Waterfall, and again, I wrote my first program as an undergraduate in 1967. I developed programs after I graduated in 1970. In 1972, I went to Boeing to develop software on the AWACS project, the Airborne Warning Control System, and we basically used a waterfall. But there were lots of sidetracks as we were evaluating new systems, and you could almost say that at the time we were working in an Agile fashion. Others might say we're just hacking. But what we did was we knew that there were, the waterfall, you couldn't keep it restricted because I didn't know everything as I left each one of my phases. So that's when I put together the Agile and the waterfall. I can then, within requirements, within design, I can actually do some development work before I get to the full-blown coding design. So Agile and Waterfall, you have to look back and forth of which one you're going to do and when you're going to do it. And I think you have to look at also what kind of overhead do I have with an Agile process? Do I have more or less in that process? And then in Scrum, again, another one of our Agile processes, and we've used Scrum quite a bit in some of the development. One of the areas in here is create the unit test before the code is written, and continue running the code and development through the test. So you can start doing those types within Scrum. Again, iteration plan, acceptance tests, stand-up meetings, peer negotiation, unit testing, pair programming, and then I get to code. But this is one of those things that goes around quite a bit. I personally like Scrum, and the only reason I like it is because I played rugby, and that was one of the So this was it spoke to me when I first looked at Scrum, and we've used it. But again, we've used it and we made sure that within each one of these steps, there was verification and validation, not just an acceptance test, but verification and validation of what we were doing. So that's the way we look at IV&V within our life cycle processes, within the models that we use for system development. Within Agile, you've got to make sure you put it in yourselves. It isn't assumed that it's there, and you have to decide what you're going to use within your life cycle for your development. And a lot of it's going to depend on the systems you're building. It also is going to depend on where all of your developers are located. So with that, that's where IV&V can occur in these. So let's look at software. Let's look at an independent verification and validation within a government agency, and this is the child support enforcement system, which was known as T2. T1 had been established on a mainframe computer using database management systems that were from the 1980s. But T1 was rated the #1 child support enforcement system in the U.S. and it was a model that that others used. So they were going to go to the next level. Part of this was funded not just by the state of Texas, but half of it was funded by the federal government. And the feds, when they came in the process, said, we want to have an independent verification and validation team. And we want that team to be available and be in Austin, Texas. And there's a group of us at the University of Texas at Austin, the Cockrell School of Engineering. Again, as I mentioned before, we'd put together the quality software project management group. And that was who the feds asked to come be the independent verification validation team. So there were between 5 and 8 of us, depending on where we were in the system. I was the code team leader. We were there for 5.5 years and did 11 site visits and engagements. And we were truly independent, truly the independent verification and validation group. The end result of this was, an article was how Texas wasted $367 million on an unusable child support enforcement system. And it didn't have to happen. This was one of those things that as part of the independent verification and validation team, they had been told where the problems were, and they were aware of where these issues were. They just chose not to implement them. So here's a timeline of events, and basically a research team at the University of Texas Center for Advanced Research and Software Engineering, RISE. We were contracted to do the semi-annual reviews on the quality and the progress. Our involvement ended in June 2016. So we went from July 2011 through June 2016, came in twice a year. We came in right before Christmas, right before the new year, and then we came in again in June. And of course, those were, since a number of the folks on the team were on faculty at UT, we had to schedule it so that they weren't teaching, because we were usually in there for 2 weeks. So that was a long start. So we started the actual timeline events. The design contract was awarded to Deloitte, and that was in June 2007. And one of the things that was interesting about this contract, and one of the things that immediately we flagged was going to be a major problem, was that the company that did the design contract could not bid on the implementation contract. So that was it. They put together a design, and then they did the requirements to the design, and then went out for solicitation. And then October 2010 was when the contract was awarded to Accenture. And then they started the software design. Now, I know you'll probably find this really hard to believe, but as soon as they started, within hours of Accenture starting, they began pointing fingers and raising all kinds of problems with the work Deloitte had done. Now, I can't understand why everybody didn't see this coming, because that's what would have happened. Accenture wanted to make sure that any problems that occurred, they could always point it back to Deloitte. The Deloitte contract was supposed to end in September of 2012, but with all the change orders issued, that went all the way up to November of 2014. And those change orders started out at 223 million, it went to 275 million, and then it went to 300 million, and finally it was 419 million after the first amendment. And so all of these went through. We were out of there by August of 2016. And the reason why we were out of there was because we had become a real thorn in the side of the folks. There had been congressional Texas Congress. There had been meetings in the House of Representatives. We had testified as to what had been going on, so it had become a real disaster. And it wasn't because their independent verification and validation people didn't tell them so. We had told them all the way along that this was going to happen. So what we did, and when you start looking at an independent verification validation, we went through the process each time. The 11 times we were there, preview, review, plan, preparation, and planning. We did that the week before we came on site. Reviewed data collection, did any analysis, did a review and revise results reports from the previous ones. Looked at the project absorption rate of the review results. Did they absorb them? Did they make the changes we looked at? Put together an action plan implemented by the project. And then T2 senior manager was a checkpoint. And we did that before we left, let them know what was going on. So it was constantly said we were doing analysis, putting together findings and recommendations. We did we would do assessments of what was going on. And so each time we came back in, we could look at usually about 5 months worth of progress and where things were. And that's what started setting off flags, as we realized right away they were not addressing the issues that we found. So the 6-monthly process, we did this, produced the IV&V management plan for the next 6 months, repeated the following for each quarterly review. So we put together a plan for data collection, performed the data collection, performed data analysis, develop and update the findings, recommendations, produce a draft report, incorporate the federal review comments, because again, we were working for the feds. We were not working for the state of Texas. So that was, we put those comments in, project review comments, we published a final report, we deliver the report, we do a management stakeholder debrief, present the results to the executive steering committee of the agency, and we'd also present it again to the federal agency as needed. And then we went through this loop. So we had a life cycle, we had a process, we understood what we were doing. And this is a model that I would strongly recommend for independent verification and validation. It's fairly critical to have a process like this in place. As we would also bring in subject matter experts as needed. We would bring them in from industry or within other academic organizations. So we had, independent, we were an embedded team. We looked at candidate issues and risks to consider to analyze further. We had product process data. We had access to all the data so we could do verification and validation against industry standards and best practices. We could do validation against the application domain model. What was the model that they were going to have in place? How was I going to look at the critical aspects, critical function reviews of this? So the process for independent verification validation is very structured, very straightforward, and is very much results driven. You've got to have in place how you're going to get those results and manage those results. So here are the exploding costs. And you can see federal budget, federal expenditures, state budget, and state expenditures. And this was accumulation as you went along, how much they were knocking off. Again, you can see it was a fairly high growth. Starting in August of 2011, this was supposed to have been a 4-year project, 4 years at the most. So by 2015, it was supposed to have been done. It was not even close. In fact, they didn't even have the designs complete by 2015. So this were some of the real interesting aspects. This was out of the quality assurance team from the Texas Office of the Attorney General, who would come in and do the reviews every year. And again, they set off red flags about this. So here, what we found out was that as we went along, our findings were basically ignored. We were kind of getting patted on the head and say, nice work, kid, good report. See you in 6 months. And then they'd throw the report away. So as early as 2011, when we first started out, we noted significant problems that really worsened over the years. The record showed how state officials failed to hold Accenture accountable as the project missed major deadlines and really morphed into an overly complicated tangle of hundreds of software bundles. It was one of the most grotesque sets of software that I had ever seen, of trying to pull things together. We tried to help the designers build matrices of these. And the problem was that, as we had pointed out a number of times through the timeline, before they could get finished with some major phases, the software that they needed was going to be obsoleted. It was going to be not supported anymore. And a good third of all the software they needed wasn't going to be supported going into production. And so this was just this constant fighting. Records show that each time a deadline was about to be missed, the state officials extended the time frame. We call it rebaselining. So that really was a way to obfuscate and obscure the project failing. And so we had pointed this out in our report. So it wasn't that no one knew this was going on. They really knew it was happening. In January 2007, Deloitte's contract updated the model for the service had an initial value of 1.8 million. Following the OAG's 5 renewal options, the final contract was valued at 46 million. System development contract awarded to Accenture was valued at almost 70 million. After the OAG, Office of the Attorney General, issued 30 change orders, the value increased to almost 160 million. So this was the constant thrashing that was going on. And it was fairly critical that, to get these things, these were out in the open, and unfortunately they were ignored, mostly along the line. So after 5.5 years, the results were the new quality process lacks any kind of quality metrics. They kept putting in new quality. They did lip service to quality management, but never had metrics. They never had KPIs that they were measuring against. Suggested a whole set of new metrics based on a goal, question, metric paradigm that we all use. Metrics should be presented graphically to management. Weren't there. A design for maintainability criteria, completely lacking in the new process. That's where you end up finding out that the tools you plan on using, the stacks of software applications you plan on using, are going obsolete. Design for maintainability was suggested, as well as measuring a maintainability index for delivered code modules. The idea of the maintainability index was something that we had put together and used quite extensively in the early 1980s when I was at Los Alamos Labs. Test code coverage goals, below industry best practice, not even close to the best practices. And the T2 project should have defined what they meant by the proposed code coverage metric, and then should apply a higher standard than currently defined. So they were looking at code coverage by each one of these applications on the stacks, and it was a crazy thing to look at because it didn't make any difference. So really, after 5.5 years, they pretty much dropped any independent verification and validation, because all we were doing was causing problems. Within months of our last report, we were called before a number of House of Representative committees who were looking into what was going on in this issue, and so that had happened. It was not a good time to be in the Office of the Attorney General when all this was going on. So this was a truly independent exercise that we did for 5.5 years. We learned a lot from it. And the one thing we learned was you can't make a customer you can't make the target of your independent verification and validation care what you're doing. Unfortunately, that's what happened. So let's shift gears from this large government system, to how do we do hardware, software as a process example. And here, this is what we do in Athens Group. This is what we do in systems. We do overall verification strategies. We put the strategies together and look at what are the parts of independent verification and validation. if I'm working in both a hardware and software environment, what do I do? So here's an example of, and I've got both of these. This is from one project, and this comes down to, in my design, I care about, do I have a design complete? And my design complete concerns my, my requirements plan, my software development schedule, my verification strategy, my alarm philosophy, and specific system-specific philosophies. Alarm philosophy, I think, well, what's that? Fire alarm? What it is that on a drilling system, a production system, an offshore system, even an onshore system, every one of the subsystems has a set of alarms that, flashlights, sound horns, if there's something wrong. Well, that's okay if you've got one system. When we're integrating these, we may have anywhere from 20 to 50 systems that we're integrating. Everything from a fire detection system to a gas detection system to the what's on the different top drives or the crown block. Where are the sensors that are there? So I have to have those around. I have to have system-specific philosophies. How do I manage these? Because I've got one or two people who are running all these, and they're doing the drilling. So how do I make sure that happens? So this is done as part of my design. I also look at the topology, and the topology is basically, what's the wiring diagram for this thing? How do I wire it all together? This is critical when you start looking at all the different systems that I've got. Some I have to make sure that I have them isolated. I can't share a server somewhere. I can't share a bus. I've got to have separate cabling for each one of these. So I've got to understand the topology. I've got to understand the functional specs. And if I've got 20 subsystems on here, I've got to make sure all my functional specs fit together in my interface specifications. I've got to be able to trace my requirements and trace my requirements from beginning to end. This is not if something goes wrong, if someone's injured, if there's an accident, or if there's a failure, I've got to be able to trace it back to what requirements did I have that made that occur, that I put those in place. Obsolescence, again, I know that something I'm buying today may be obsolete within months, but I have to have it because I've got to fill this need. So I have to decide, how am I going to maintain it? Do I do outside people to do the maintenance for me? Do I train my own people? What do I do with that if it's going to be obsolete? And then novel usage. And this is an area where you're constantly getting new things. Think of putting drones. If I want to put drones on a vessel to do inspections, how do I get that data back and forth? What do I do for subsea? How do I handle the data coming back from subsea? Is that novel use that has to come into the system? So then I declare my design complete. We've done some of those steps. We don't do all those steps. All those steps are done. There's hundreds of people doing those steps. We come in and we say the design's complete. We're the ones that stamp it. Okay, we've reviewed it all, it's complete. Now, the next thing that's going to occur is I've got a failure mode and effects analysis, FMEA, and could be an FMECA, criticality analysis. It also could be a HAZID or a HAZOP, which is hazard identification or hazardous operations. I can do that before or after the design is complete. Most times, I do the HAZID and HAZOPs as part of my design completion. I do the failure mode and effects criticality analysis, internal tests and internal test analyses after the design is complete. So once I've gone through that with all the pieces, all the sub pieces, and I've basically stamped them off, I'm now ready for a FAT. Well, FAT is factory acceptance test. And the factory acceptance test then says, okay, here's what else I have to do. I've got to do a hardware in the loop test, an HIL test, which basically is a simulation. I don't have the hardware. I don't have all these pieces of hardware. They may all be on the ship. So I don't have all these pieces of hardware. I'm going to simulate some of them and then do the testing. We oversee the testing. We oversee the factory acceptance test. We will probably write the release notes, or we'll write the release notes in concert with the manufacturer. And then I go to ship the system. Well, once I've shipped the system now is going to be installed on the vessel, in somewhere within the operational area. And I got to make sure I fix everything on the punch list. So I got punch lists from the factory acceptance test and the hardware in the loop test. I'm going to remediate any of the risks that I've identified in the failure mode analysis. And then I'm going to do an internal retest. And this is all part of the independent verification validation. I make sure that the punches have been fixed, or I make sure I remediated, or they've remediated the risk. Then I oversee the internal retest. And then we do commissioning release notes. And so now it goes into commissioning readiness. This whole time we're doing subsystem by subsystem. We haven't even addressed the entire vessel yet. So now we look at commissioning tests. And the commissioning tests are usually done by the owner and the shipyard. So there's lots of stakeholders here, lots of moving parts. But the commissioning tests, the integration tests are all overseen by us as the independent verification validation folks. We make sure that the punches have been fixed, it's been retested, and then we do an as-built release note. So this says, this is how it was built. Here's all the bits and pieces that are there. So everything's in place, and now you can go into acceptance test readiness. So this is how in the real world, where you've got mission critical systems, where you've got aircraft, where you've got ships, where you've got autonomous cars. These are the types of independent verification validations that we go through, that you must go through when you look at all these steps. And these are, we've got equipment, again, just the equipment on one of the last ones, the drilling equipment was done some was built in Norway, some was built in Germany, some was built in the US. The shipyard was in Singapore, or the shipyard might have been in Kuala Lumpur. Everything's on the drilling, the testing may be done at the simulations, and everything may be done at various hardware vendors, or they may contract to somebody else. So this is a worldwide operation, lots of moving parts. So you've got to have a formal process to ensure that you don't drop the ball somewhere along the line. So the target, when you look at requirements traceability, where target's always greater than 70% coverage of requirements by the factory acceptance test. You're not going to get 100% coverage, but you know that, and you also know which ones and where you don't have the coverage. So at that point, if you have to go back, you can go back and you can look at these, because you've really notated a lot in the requirements traceability. And some of these are done by the factory acceptance testing, possibly that many times that almost 30% is due to other tools that are being used, or other applications, or other pieces of hardware. The goal on commissioning now is to get me to 90% coverage by the end of a single system commissioning, which means that I'm going to commission the drawworks, I'm going to commission the dynamic positioning system, or I'm going to commission one of the navigation systems, until I get to integration test. And in integration test, I've cleaned up the 30 from before and the 10 from before, and I'm now at 100%. So in order to do the integration testing before acceptance test, I'm going to have 100% coverage. This type of layout is again, incredibly important to get that 100% requirements coverage. If you don't have it, if you're not at 100% requirements coverage, and you can prove you're at 100%, then you're risking a lot to make sure that, requirements, they may not have gotten dropped, they may just have been implemented incorrectly. So you may have not built the right system if you don't get all those requirements down right. And we've seen it where we've walked into the middle of some of these where the previous steps hadn't been done. And again, it becomes pretty painful going back to factories and making them, reset up the testing systems and reset everything again, because we want to make sure we've got it tested right. But this is the critical area. And again, these are for mission critical systems. You don't want to have your aircraft not be 100% coverage, or then you might be in the 737 MAX, and then you're in another different environment completely. So focus on IV&V. We talked about where it is in the development life cycle. And again, you've got control over this in your development life cycle. You've got control over how you want it to be and how you want it to evolve. Went through our government example. Again, this was 5.5 years of going in for 4 weeks a year and being incredibly frustrated by not being able to get them to change what was going on. And then we went through the hardware software process example where you're looking at mission critical systems. So this was our fumble. You want to make sure you avoid the fumble as much as you can.
Thank you very much, Don, for presenting with us today.
Thank you, Susan, and thanks to all the attendees. Enjoyed it very much. And again, please reach out if you have any questions. I'd be glad to try and answer them for you.
Great. Thank you. Thanks, everyone. Have a great day.
Good holiday season. Cheers.